Hi, and welcome back. DeMarty has stepped out. Adam and I are going to talk to you about SQL Server data tools for Visual Studio. I am Eric Ellis. Adam Mahood will be doing the demos. Hi, Adam. So we are program managers in the SQL Server Database Systems group inside of Microsoft, of course. We work on the engineering team. We're engineering leads for the database developer tools, both those that integrate into Visual Studio and those that are in the portal, in the Windows Azure portal, and several other spots around the ecosystem. Our background specifically is in database development approaches utilizing DACFX. We are here to talk today about the developer-focused tooling. And so the 6 pieces that I want to cover, or that we're going to cover today, really are our exceptional support for SQL 14, SQL Server 2014, how we've updated the tool stack to leverage those capabilities. En route to that, we're going to talk about SQL Server Declarative and Imperative Toolset in general in Visual Studio, and how those features are exposed in a couple of, actually 3 key scenarios. We're also going to cover some features that have been in a brief hiatus in the product. So we're going to cover data comparison, which was out of the product for a year or so. And then we're also going to cover the Windows Azure tooling integration piece, where we've made some inroads there into exposing SQL Azure Database. And the last couple things are a little bit of miscellany, but we're going to cover the DACFX extensibility story, and how if you run out of flexibility, we're going to be able to open those models up and have some build and deployment contributor pipelines that you can access. And then the acquisition model and SKU support. It sounds a little bit boring, sounds like we're going to be talking about a hyperlink to go to, but actually there's some interesting points to be made there. We have the product is exposed in 3 different versions of Visual Studio, a couple different SKUs, so we'll talk about that as well. So when we talk about SQL Server database tooling, we really try to split it up into 3 bits. That is the developer-focused tooling, the manageability tooling, and the business intelligence tooling. And these really are 3 different things that work in concert with each other. Today's talk is going to be about the developer-focused tooling, specifically that is exposed in Visual Studio, and also known as SQL Server data tools, with no suffix, no business intelligence suffix. We're going to be talking about the T-SQL toolset. The manageability toolset, as contrasted, would be SQL Server Management Studio, classic VS-hosted manageability, performance tuning, and that type of thing. It's Windows Azure Management Portal, which is the SQL extension inside the standard Windows Azure Management Portal, and then SAMP, which is SQL Azure Management Portal, which is the managed link from the standard Azure portal. Business Intelligence is SQL Server Data Tools BI, also known in the past as BIDS, and Power BI. We won't be covering those things today, but in the session immediately following this one, we'll cover that in quite a bit more depth. Okay, so let's click into the developer tools and framework and how it's exposed in Visual Studio. And that is, when we talk about the developer tools, we're really talking about that set of tools you would use to go at T-SQL, but eventually target SQL Server or Windows Azure SQL database. You can work against a live database, you can do offline, you can have source code in projects, and the tooling really sits on top of DACFX, which is the engine that does the heavy lifting for the tool set. And this heavy lifting that it does is it does reverse engineering, it does the comparison engine, it also writes packages, reads packages, and provides all the analysis and algorithms that really make the engine go. So the declarative model that we'll talk about in quite a bit of detail will be covered. That really is DACFX shining through in the tool set. And so the exposure we have for DACFX, besides the tools that are going to be demoed here today, would also be covered under SQL Package, which is a command line tool. We have a managed API over the top of that. And probably one of the most critical things I want to mention today is that DACFX sits under SSMS and the import-export service. It also powers several other data deployment stacks within the Microsoft ecosystem. And with that, it provides a centralized, fully compatible package transport format so that you can ensure that if you're using DACFX, that database is going to be read into and properly interpreted by those other tool streams. Okay, So let's look at SQL Server Developer tooling. We really break this down into 3 scenarios. One is the connected development scenario, and that is very similar to your classic SSMS style development where you're working on T-SQL directly. That T-SQL is entered into some sort of editor, and then when you execute, you're literally shooting a T-SQL stream right at the server. So the changes are immediate, and this approach is fully supported in our tooling. We have a navigational tree that can connect to servers. You can enumerate objects. You can inspect properties without making any changes. And in our tool set, we also have a table designer, which provides a connected exposure, view and edit of data. You get some validation and IntelliSense. And our data comparison feature that we'll talk about briefly would also be lumped into a connected development. It's great for ad hoc, immediate changes. And we pride ourselves on providing a set of tools where we're not going to prescribe exactly how you use the tools, but we're going to try to match our tool set with how you want to work. And many people work in this direct connected development environment and have for years. It's a very high productivity environment, and it's one we support very well, very similar to SSMS. So our second main scenario we enable is the project-based development, and this more actively utilizes the power of DAC effects and the power of a declarative environment and the power of this design time modeling. So in this approach, you're going to take your database and shred it into bits. And those bits that you shred it into are going to represent the individual objects in your database. And once those are shredded into code files, you're going to be able to treat them as code files. And you're going to be able to utilize an application developer standard of development, which is going to be a check-in, check-out for source code, or you're going to be able to do track changes and that type of thing. So it's going to build, it's going to harness other features inside of Visual Studio to your advantage, like go to definition, find all references. You're going to have one set of source code that can be targeted against multiple different targets. And so as soon as you decouple yourself from that immediate execution that you get with connected development, you really bring a lot of this power to bear. You also have a much richer pre-validation step in that you can try out your changes in a more localized environment. And I don't want that to be strictly taken as on your own machine only. It actually could be on a shared development server that's a database server, but it likely isn't production. It's likely an earlier stage of that. And so we feel very strongly that project-based development is the best place to do serious professional development. It's also great to do migration tasks, which Adam is going to demo today. And in terms of tracking history, version control, or other tools add-ins, it's definitely the way to go. And I didn't mention it, but our project is a standard Visual Studio project. It can be part of a build, multi-developer scenario. It fully supports the ALM stack. You can automate it. So all that stuff is there for you in the project-based development. The last scenario, or the core scenario that we want to talk about, is schema deployment. And schema deployment is something that maybe even if you weren't a developer or doing development-based tasks, you might use this set of tools. And that is, we have a very rich visual schema comparison tool that comes with the tool set. You can automate project publishing, so you could take your project, which actually builds to a DAC pack, so it really should be DAC pack publish. The schema deployment can also generate a script, so if you need to pass off your script to a DBA or somebody else to do a code inspection of that script, if those are the type of control systems you have in your environment. So the schema deployment tool set is actually very, very rich. We talked about SQL Package EXE being a command line utility over the top of DAC effects, so you can have a smaller non-VS footprint that you can carry around with you to do deployments. And we have a whole slide dedicated to extensibility, and we have an extremely wide open model for that now. Okay, so we've talked about the different tool sets. We've double-clicked a little bit on the capabilities inside of Visual Studio that we have. Now I want to talk a little bit about the specific support we have for SQL 14. So those 3 scenarios that I talked about, connected, project, and schema deployment, are all supported with SQL 14 today. This isn't something that's going to come later. We've got it working right now. You can go out and grab a CTP2 copy of SSDT and give it a try. We've updated the templates and all the support for those in-memory OLTP and column store objects that are so popular and getting so much positive, press and feedback are supported in the tool set. Not only that, because I talked a little bit earlier about DACFX being at the base of that tool set, that means that anywhere that DACFX is used, the tool set will also support that. So you have a compatible package for moving through the pipeline. And the other thing it's exciting to have is that we have plans in place for full support for SQL 14 inside of Visual Studio 2012 and 2013, right when SQL 14 releases to manufacturing, or RTMs, goes live. So we're very excited about that. So with that, we'll hand it off to Adam Mahood, and he's going to demo a migration and hackathon development scenario. And I'll hand it over to Adam.
Thanks, Eric. As Eric mentioned, what we're going to be doing today is looking at some development, looking at the first-class support we have in the Visual Studio database tools for SQL Server 2014. Specifically, what we're going to do is take a look at the migration scenario and look at taking an existing SQL Server 2012 database that's running our production application and migrating that out to SQL Server 2014. Now, as we go along, what we're going to do is add support for various in-memory OLTP objects to get the performance gains that you get with the feature set Eric was talking about. So with that, let's go ahead and get started. I'm here, let me do some window cleanup here. So I'm here in Visual Studio 2013 Express for Web. This is a little bit of a preview. These are private preview bits of what's coming down the pike, so a little bit of sneak preview for you guys. I know I'm going to be doing a lot of schema development, but so I could do that first method that Eric talked about, and that's work directly connected against the database. But I want to take advantage of a lot of the isolation and the productivity enhancements and benefits you get with the project system, so that's where I'm going to do most of my work. So in Visual Studio, I'm going to do File, New Project, and create a new SQL Server database project. Now, this one database project type covers it supports all of the target platforms that SSDT and DACFX support from SQL Server 2005 up to 2014 in Azure. So we're going to be working today on my cardealer.com application. So let me call this cardealer.com. Go ahead and create this directory, and we should be off to the races. And I don't want properties right now. I would rather have Solution Explorer. Let me see if I can get that here. There we go. Okay, so what I want to do, so this is just a stub SQL Server database project. What I want to do is hydrate this guy with an existing definition of my production database. So if I right-click on the project, you can see I have a couple options to get started, or import. I could import from a live database and do basically reverse engineer that database into source code. I could import from a handful of T-SQL declarative script files. But what I'm going to use a DAC pack that I've already created from my production database. And what a DAC pack is Eric touched on it a little bit, but it's really the fundamental common schema transport format across the SQL Server client tooling. It represents a blueprint of your database schema, and that's the best way to think about it. So if I go browse, I'm going to pick this cardealer.com DAC pack. And again, you can extract a DAC pack from a live database containing the schema, just the schema, or the schema and the data. And you can do that from a variety of tools like SSMS in SQL Server Object Explorer right here in SSDT. So you have a lot of options of how to get one of these DAC packs from an existing database. So I'm going to import database settings, leave the rest of the defaults in place, and go ahead and kick this off. And what this is doing is basically cracking open that DAC pack, inspecting that model, and building a full fidelity logical database model from that schema blueprint. And then taking that model and shredding it down into individual T-SQL source code files representing all of my objects. So if I go over here to Solution Explorer, expand, you can see I have DBO folder for my schema, and then all folders for tables, views, stored procedures. So if I just click on one of my stored procedures, delete car, I get a source code file just like I would for any other project, and I'm working against the declarative, in a declarative manner, against the definition or create statement for my object. Okay, so now this is a source code representation of my production cardealer.com database. I want to do a couple more setup things before we get into the meat of the development here. So if I go to Project Properties, I want to change the target platform to SQL 14. Now, this notion of target platform is really powerful. This setting basically tells DACFX against which platform to do its robust and rich validation. And so that it's going to look at that platform and say, okay, I know I'm going to target SQL Server 2014. Let's validate the contents of your project and your logical schema model against the requirements of that platform. So by changing this to SQL 14, I'm now getting immediate real-time validation against the SQL 14 platform requirements. So that's goodness. The other thing I want to do is change my default debug database. Now, one of the main benefits of working in the project system is that you get this rich, isolated debug development loop like you would for a C# application. You make a change in the project system, you can deploy it out to your local database or your local instance and do real-time validation. By default, you can see here we set you up with LocalDB, which is a lightweight file-backed version, basically SQL Express. But I'm going to retarget a live database since I don't have a version of LocalDB that supports SQL 14 yet, so I'm going to change this to my local SQL 14 instance. And we'll just call this my cardealer.com debug database. Let me save that. Okay, so we've done a little bit of setup. The last thing I want to do before we really get cooking is to make a baseline of this project. Now, what Eric and I would normally do, if both of us were working on this project together, we'd check this project into source code control now, so we could, make real-time edits, get change tracking, and leverage all the benefits of team development. But since I don't have source code control right now, I want to use DACPack snapshots instead. So if I come up here to the project and click Snapshot Project, what this is going to do is basically compile another DACPack for me and automatically add it to my project. And this DACPack contains the blueprint of the schema definition of my project at this point in time. So I now have a single file representation of my baseline cardealer.com database with this target platform set to SQL Server 2014. So with that in mind, I think I'm ready to just do my first debug deployment out to my debug database and get up and running on SQL 14. So just like I would in a C# app, I can just do an F5 or start debugging. So let me go ahead and click this. And this is going to connect to my local SQL 14 instance. And if you look at the output, it's going to first create my database since it doesn't exist yet, and then deploy each of the objects that's defined in my project. And it looks like everything worked quite well.
You want to zoom in on that maybe?
I would if I knew how very quickly. Unfortunately, I don't have to zoom it right now.
Okay.
But I will zoom in when I get a chance. Let me go over to SQL Server Object Explorer. And this window is really your home for, now if I can get my clicker here, database development activities inside Visual Studio. And what Eric talked about, that first column, really the connected development experiences, SQL Server Object Explorer is where you're going to find launch points for most of those tasks. So creating or dropping databases, initiating a schema or data comparison, anything along those lines. So if I refresh my databases node, here my cardealer.com debug database. Looks like all my tables and views made it okay. Let's check that sprock that I looked at in the project. Let me right-click View Code. And again, the exact same definition as I started with in the project. Looks like my deployment did go as planned. Let me get myself some more screen real estate. So as we go along, I said we're going to be adding support for in-memory OLTP to get performance gains. To measure that, we need to take an initial benchmark. So to do that, I'm going to come up and right-click on my database and click New Query. And this launches me into the familiar T-SQL editor that you'll find in SSMS. Again, it's that familiar way of working that we've brought into Visual Studio. Now I have a script here already ready, so you don't have to watch me type today. And now I will zoom in a bit, perhaps a bit too much. Some overzealous zooming there. Basically what this is going to do is our crude benchmarking tool. We're going to go through and in this dbo.value table, we're just going to go through a while loop and insert 100,000 rows. And we're going to see how long that takes. And value is just a simple table with a primary key int column and an nvarchar that we're going to stick this value in 100,000 times. So nothing fancy, but just a nice way of getting a baseline benchmark. So I'm going to come up here and execute this guy. Oh, I did that last time too, highlighted that value. Let's actually run the entire query. So as this churns away, one thing to keep in mind is that I'm running actually on a Windows Azure virtual machine right now. So this whole thing is being, the whole SQL engine is hosted up in the cloud. So, whatever latencies we get, we're up in the cloud. So we'll see what we end up with here. Okay, so it looks like our SQL table with clustered index. I'll copy that out into another notepad. Looks like our baseline is about 9.5 seconds. So it's a pretty good baseline for 100,000 rows. But we want to get some perf gains. So to do that, I'm going to go back to project-based development and add a hekaton table. So what I'm going to do is what Eric and I like to refer to as hekatonizing this table and taking this values table from a standard T-SQL table to an in-memory OLTP table. If I want to go up and add, to show you some of the templates that we've added for these new SQL 14 objects, let me go to New Item. And you'll see, type in memory. And you see we have memory optimized file groups, table, this combo table file group here, which is really handy. This pops you into our new table designer, which has two ways of working, either a graphical user interface, a nice columns grid if you prefer a UI approach, or if you're just a T-SQL guy and you like working against T-SQL script, you have that method of working down here as well. I'm going to delete this guy because I already have a script prepared. So let me view code on our existing value table. Oh, I want to comment out this guy. Grab my script. Okay, let me zoom in a bit. So let's take a look at this. So a couple things to point out. First, you can see we're adding our hekaton file group to the project. And before you can add any hekaton objects to your database, you have to have a file group that contains memory optimized data as the home for all of your in-memory OLTP data. You can see we're using SQL command syntax, which is another great productivity booster we give you in the project so that you can define variables and use them throughout your project for targeting different environments or using different security scenarios. Database name is one of the built-in variables that we give you, and we use that, pick that up by default here. So let's go down to the table definition. You can see with these two side by side, there really isn't a lot of differences between the two definitions. In the new table, you'll see we've gone from a primary key clustered index to a non-clustered hash index. Hash indexes are the required index type on all hekaton tables, so we stick that on there. And hash indexes have this thing called a bucket count, which really basically is how much memory is allocated for the data in this memory optimized table. The guidance from the hekaton folks is that the value for your bucket count should be about 1 to 2 times the expected number of unique values you anticipate in this index. So since I know we're working about 100,000, I'm going to stick it up about 500,000 just to give a little headroom. The other two things to point out here are this memory optimized flag, which is the high-level bit saying, hey, I'm a hekaton table, and then this durability. So durability defines what you want persisted on disk across SQL Server sessions or failures. In this case, I don't need the data in this table persisted, so I'm going to only persist the schema on disk. Okay, so we've got our table definition modified. I want to just do another quick F5 deployment out to my debug database, so I'm going to kick that off. And you'll see as we go down in the output window that we're not starting from scratch. We're not rebuilding that database. We're not deploying every object every time. Under the covers, DACFX knows that debug database already exists. So it's doing a targeted comparison to understand the differences between your project and the database, and then crafting an incremental deployment script of the minimal set of T-SQL necessary to update the target. And so you can see we added the file group and we rebuilt the table. Let me double click on this guy to get to the actual script that was executed. So you see a couple things. Here we're just adding, minimize that. We're just adding the file group and file, and it picks up that database name command variable. And then we're rebuilding the dbo.value table. And you may say, hey, wait a minute, why are we rebuilding a table here? I only changed a few properties. Well, DACFX understands that hekaton tables don't yet support alter syntax. So under the covers, it knows that it needs to do the table drop and recreate in data motion around that syntax element. And if you look at the syntax here, it's not particularly clean. So imagine if you had to write this for all of your tables. This is really the power of DACFX here, is crafting this incremental deployment script so you don't have to do it by hand. So let me close that out, go back over to SQL Server Object Explorer. Now there are no new objects aside from that file group, so I can really just go back to my query window. And you may say, okay, what all do we have to change in this benchmarking script to work with the hekaton table? And the answer is just the comment. think about this from an application access perspective. I don't have to change anything in this benchmarking script to work with this hackathon table. If this is my data tier of an application, I don't need to do anything fancy to get this existing application to be able to start leveraging the power of in-memory OLTP. So let me just go ahead and execute this guy again. Let's hope the demo gods are on our side and get us a good perf gain here. And it looks like we actually have, just by doing a few clicks in the project system, a few T-SQL changes, we have about a 10-fold reduction in our while loop. So getting some awesome perf gains already. However, we are not done yet. The other main object that is part of the in-memory OLTP feature set is natively compiled stored procedures. And what this object allows you to do is basically craft regular T-SQL stored procedures that get compiled down into native machine code by the SQL Server engine at runtime. And that, again, gives you awesome raw performance benefits. So I'm going to come up here, go back to my templates, add a new item, do a search for natively compiled. You can see there's that handy template again. We'll call it insert value. And before you can see that, I'm going to pop in my final script. And as you see, the meat of this store procedure here is exactly what was in our benchmarking script. So what we're doing is inside a while loop, inside this proc, we're inserting 100,000 rows or whatever value you pass in as the input parameter, and executing that, inserting those rows into the value table. Now, a couple other hackathon-specific syntax elements I want to point out. With native compilation, again, this is your high-level bit saying, hey, I'm a hackathon procedure, treat me with the appropriate kid gloves. Schema binding and executing as owner. All natively compiled stored procedures have to be schema bound and executed as the database owner. And then this last begin atomic with says, tells the engine to treat the rest of this proc body as a transaction. So one thing before we deploy this out, I want to point out some of the great first-class support we have for T-SQL inside the project system. So if I right-click on the identifier, you'll see that we have some of the things that most app developers have taken for granted, and that's things like refactor rename, which will do a logical find and replace inside your project. If I go down to the value table, I can do go to definition, which is going to take me right to that table definition. The inverse, I can find all references. Again, I don't have that big of a project, but you can see it finds all the references to that value table, including the procedure. So let me go back there. And I'm about ready, I think, to do my final debug deployment. So let's kick this off. Looks like it worked. So let me go over to get some real estate here, refresh my stored procedures folder, and here we see this new insert value proc. Now, instead of crafting some T-SQL, I'm going to leverage this handy feature we have in SQL Server Object Explorer, one of those ad hoc tools, to directly execute the procedure. So you get a template with all of the variables that you need to specify. I'm going to pass in 100,000 because that's the number of rows we're going to do. And this is going to create a little execution harness, wire up my procedure, and kick it off. So let's see what our final perf gains are. And the drama. And looks like we're doing pretty well. Let me copy this out so you can get a better look. And it looks like we've gone from just about 10 seconds down to sub 1 second, and now we're down to 78 milliseconds by wrapping that while loop inside a natively compiled stored procedure. And again, it is a bit of a crude benchmark, but it's really valuable just to show you, along with the first-class support you get in the project system, the perf gains that you get with these objects. So one last thing to look at sort of how far we've come, I'm going to use schema comparison to look at the current state of my project and compare it to the baseline DAC pack that we started with. So let me right-click on the project, do a schema compare. And because I launched from the project, it automatically sets that up as my source context. And for my target, I want to pick that baseline DAC pack I created. So in schema compare, you can compare either a live database, a database project, or a DAC pack to any one of the other three. And so I'm going to use the project to DAC pack combination here. And we're kicking off a comparison. Again, DACFX can craft the same logical model from any one of those source representations. So what should we see here? It looks like we have our value table is changed. That's expected. We made it a hackathon table. We hackathonized it. We added that insert value proc, which is that natively compiled stored procedure. And there's our hackathon file group that stores all of our, effectively, hackathon data. Now I'm sort of done with my debug loop, and what I can do is now break out of that debug loop and publish this project out to my test or UAT. This is what I would do at the end of a development cycle and push that out to my test environment. So if I go to my database, right-click, and select Publish, here I just want to pass in my credentials, actually server name. And we're going to call this test. And we're going to publish away. And that sort of wraps up my piece of the demo as we deploy out to our test environment. What we've basically done is taken a live SQL Server 2012 database, migrated that out to SQL 14, and along the way we've used the great support you get for SQL 14 in the database project system to add support for Hackathon and look at the perf gains you get with in-memory OLTP. Now I'll kick it back over to Eric for some slides.
All right. Thanks, Adam. A little bit of a change of direction, but great demo and great performance improvement there, and we took a peek at Publish at the end. So data comparison was out of the product for about a year. When we replaced the previous set of tools, one of the things that we was missing was data comparison. And data comparison is a great tool for selective comparisons of small and medium-sized data sets. And it not only will compare those data sets, but will also make the requisite changes to bring the compared data set up to the same sort of stamp. It'll basically drive differences both directions, and you can end up with two identical data sets. So it supports for all data types, 2005 and up, and the entire product stream that we've talked about has this same server support matrix. One of the things that we talk about data comparison, sort of the data comparison is very good for what it's for and not so good at what it's not for. And that's a little bit hard to say, but if this is not a heavy-duty data curation or transformation tool, it is not something that is automatable from the outside. But what it's good for is that ad hoc, small and medium-sized data sets. It works for what you want to get done. Another question we get frequently around data comparison is data generation. And data generation, unfortunately, is not planned currently. And to automate data generation for use with database unit testing, you'd have to use third-party tools for that. Okay, so this gives you a quick take a look at what a data comparison UI might look like in the product, where you have two different same schema databases. You can pick a selection of tables, and you get a very good graphical representation, highly accurate. It shows what's identical, what's different on one side, the other side, and you can actually script out the changes necessary to make those and execute those separately. Okay, so let's take another left turn here, and let's talk a little bit about integration with Windows Azure Tools SDK. So there's a new Windows Azure node in Server Explorer, and we talked a little about SQL Server Object Explorer. There's another window in Visual Studio called Server Explorer, and that's where you have a server, or historically have had a server-based view of things. The Windows Azure node now supports SQL Database, and this gives you a subscription level view over your SQL Azure assets, rather than in SQL Server Object Explorer, that is a server-specific view, or even in Data Connections, if you go back historically back farther, Data Connections is a database-specific view or a connections view. So this exposure of SQL Azure in the Windows Azure node is fundamentally a navigational aid and a discovery aid. The development tools that you've seen here today in SQL Server Object Explorer can be linked into from this exposure in the tool set. You can also link up to the portal experience that you would use for your Azure assets. Let's see if I missed anything. Nope, that's great. And in 2013, we support website databases and mobile services, and then if you get the full Windows Azure SDK, additional services will be brought online. And right now, our support for SQL Azure Database is in Visual Studio 2013. So let's take a look at a quick demo, another one from Adam, on how to set up your subscription, how to do some simple navigation, and go from there.
Let's do it. So what I'm going to do is basically show you how to get your Visual Studio 2013 Windows Azure node hooked up to your Windows Azure subscriptions so you can use that great functionality that's been brought down into VS. So here I'm at the home page for the Windows Azure Standard Management Portal. You can see I have a broad view over all of my different assets across the different services and my different subscriptions. If you go to the Databases extension, again, this is just a top-level view of all of my databases across all of my different accounts and subscriptions. So if I go back to Visual Studio 2013, I'm here in Server Explorer this time. Note the context switch from SQL Server Object Explorer to Server Explorer. I have this Windows Azure node with all of the different supported services listed under the side. So what I want to do is basically connect Visual Studio with my subscription in the cloud. And we do that with certificates. And so I want to get started here by right-clicking on the Windows Azure node and select Manage Subscriptions. Go over to Certificates and Import. And if I click this download subscription file, what this would have me do is go up to the portal and save a file locally. And that process, saving that file, would also upload that same certificate up to the management portal. I already have a cert downloaded locally, which is what I'm going to use now. But it's just a couple clicks, and you can make that link in a few seconds. So let me go browse to my desktop, grab my published settings file, and import that. And you can see it grabbed both of my subscriptions from my account. And if I go back to the portal, in fact, go down to the settings extension, management certificates, you'll see that it automatically uploaded that certificate without me having to do any of the SSL or cert magic. Without having to do any of that, it automatically set me up for success. So let me go back to VS, close that. And now a lot of that, if you're an app admin, you spend a lot of time in the Azure Management Portal doing provisioning or management tasks. With this Windows Azure Node functionality, you can now do a lot of that inside Visual Studio to help you bridge that gap. And so if I navigate, you can see some of my cloud services. You can actually see the virtual machine that I'm currently running on. If these will, looks like I need to feed it some coffee. It's a bit late in the day here. There we go. So there's my Admahood demo. So it's sort of a bit recursive here, a bit meta. My different endpoints. Here's my cardealer.com website, should pop up here. And if I do something like click on the virtual machine, I have some powerful gestures and launch points. So I can connect to RDP directly from VS. I can restart and shut down the VM. The website, if I launch in and view the settings, you can see that in my connection string, I have a linked database. And that's not something that you could, it's not a link or a connection that you previously could have understood without going to the management portal. But the real sweet spot here is what we're here to talk about is SQL databases. So if I expand this, you're going to see that same view that I had in the portal, which is all of my databases, regardless of server, in all of my subscriptions. So here you can see the database that's powering my mobile service, my website. If I view properties of this guy, you'll see that it's in the East US data center, this particular server, and this subscription. So a lot of great information here. What you can do now, if you want to get into a bit more deeper database development like we've been looking at, we have a launch point for that from this node. So if I right-click on cardealer.com web, I can open in SQL Server Object Explorer. Now the first thing it's going to say is, hey, you can't access this database yet because you don't have any firewall rules. By default, all servers are created with all the firewall totally blocked down, and it detects that, and it's allowing me to quickly add a new firewall rule for this IP. So let me do that. Type in my credentials and connect. And now in SQL Server Object Explorer, it's going to automatically populate a connection directly to that database without me having to do any of the wiring up. So you can see I have my cardealer.com web database. And if I want to do some more development, I'm off to the races here. I can create a new project or do some ad hoc schema or data comparison like a lot of the other scenarios we've already taken a look at. So that's really a quick look at how you can get up and running with this powerful new Windows Azure Node functionality in Visual Studio 2013. And as Eric mentioned, look for more to come in this space as we continue to grow on some of these Windows Azure SQL database scenarios inside Visual Studio.
Great.
Eric?
Great stuff, Adam. Adam, when he went to publish at the end of the first demo, he talked about a couple of the different options that were available. We didn't show those directly, but there's about, I think, somewhere between 70 and 85 different deployment options that you can do just built into the project system, built into the DACFX deployment pipeline. Those are what you get out of the box.
Yep. At
some point along our development cycle, we decided that adding one more option and one more permutation of those things was getting pretty difficult, and it honestly wasn't meeting every customer's need. And so what we've really put a lot of effort into is opening up our extensibility pipeline, both the build and deployment contributor extensibility pipeline, so that you can programmatically extend any of those events. You can trigger those off of particular things within those pipelines. And even particularly near and dear to my heart is that we've opened up the Schema Model API. And the Schema Model API enables you to inspect, write, or alter one of those database logical models that we've been talking about for the last 40 minutes or so. And that is any of those models that get created, or if you want to create one yourself, you can inspect and extend those. And we have some extremely interesting tooling scenarios for that, where we've partnered with the LightSwitch folks in terms of their design time experiences in Visual Studio, writing to a dynamic model as their customers then create LightSwitch apps. So very, very, very powerful stuff. I will put a warning in, not light duty,
not for the faint of heart.
not for the faint of heart, and can be exceedingly dangerous. We all know that database development has a bit of an edge to it, and there's not a lot of undo on some of these things. So you're going to have to work pretty hard to make this fit for you. But if you have a business need, you have a particular scenario that you need to enable, this is that opening for that. And one thing I wanted to mention for the extensibility is that went live in June of 2013 this year. So if you haven't grabbed a refresh set of bits, that went live in June, and that's for 2010 and 2012. But in 2013, it's like that out of the box. Okay, let's talk a little bit about acquisition and SKU support. A little bit of a complex topic. It really shouldn't be, but I think we've arrived at a place where we have a really clean model from here going forward. If you wind the clock back in 2010, we were an add-in because we weren't part of the Visual Studio baseline. In 2012, we were part of the Visual Studio baseline. All the tools you've seen here today, minus a couple of the new ones, were there. But you had to install an add-in from the web in order to get automatic updates. With 2013, all the tools are there out of the box. They're in all the Express queues, and the integrated in-shell notification and delivery is the same exact pipeline as Visual Studio. It's a very clean story, and one we're actually really proud of. And the reason that I've included this future Visual Studio column is not because there's any changes there, it's because there are no changes. We feel like we're at an end point in terms of a tools acquisition, a versioning story, and a platform support story. For example, one of the things that we're most excited about is really delivering SQL Server tooling for SQL 14 the day it ships. And by delivering it, we mean in Visual Studio, you'll get a prompt that says, download the latest and greatest DACFX and SSDT, hit a couple of buttons, and you're good to go, targeting SQL 14 that day. If you read in the pay row here, we do have 3 features that are only available in the Pro Plus SKUs. And that is SQL CLR authoring, SQL debugging, and database unit test authoring. And those really aren't a function of anything else besides the dependencies upon which those rely are in the Pro SKUs only. Updates, we talked about in-shell notification for 2010 and 2012, but you do have to install SSDT at least once from the web. From there on, you're going forward. And in 2013, it's built in. Okay, so platform support. In Visual Studio 2013, full database tool set available in-box in all the SKUs. We talked about the 3 features that were in the pay SKU. If there's one thing that I want people to take away from this discussion is that the DACFX transport format and the project format in Visual Studio are 100% compatible from 2010, 2012, and 2013. If you make an investment in these technologies and these formats, we have made a pledge to keep those compatible going forward. So if you have a mixed shop where you've got developers on one version of Visual Studio, maybe an Express queue on this machine, 2010 pay on another machine, those artifacts and the multi-developer scenario are going to work for you. It's going to work actually seamlessly. It works extremely well. Okay, so what have we covered? We covered the tool set on the whole, the declarative and imperative pipeline, schema comparison, the deployment stack. We've talked a lot about SQL 14, did a fantastic performance demo where we wove through all the different capabilities of the product. We've really announced data comparison again. It's been out for about 5 months now, 6 months. We've taken a look at how we've opened up some discoverability and centralization of your Azure assets under this Windows Azure node for SQL database. And I think this isn't as deep a talk as we've sometimes done around deployment and extensibility, but let me tell you, your flexibility here is incredible. You can pretty much do anything you want. And then acquisition and SKU support, an area of confusion in the past. We want to make sure that's 100% clear and the messages there are 100% understood, and that is SQL Server platform support in the tool set you want to use, how you want to use it. So with that, thank you.
Yeah.
On behalf
Thanks
of
a lot.
myself and Adam, thanks for your time. We have some additional resources here. We've got an active blog. Like I said earlier, you can go out and grab CTP2 today. You can play with it. SQL Server is available out there. And I think that'll pretty much wrap it up for us. And we have about a 15-minute break here, and then we'll be talking about, I believe, SSDT business intelligence. Well, thank you very much.
Thanks, guys.